So the question is, a vector of magnitude b is rotated through an angle theta. What is the change in the magnitude? In order to visualize that, we need to draw the vector. So let us assume some vector b vector. So let us draw this vector. Let's say this is our b vector. So we are trying to rotate this vector. So when you rotate, let me rotate this vector. So I am rotating this vector. Okay, either way you can rotate. So it is through a small angle theta we have rotated. Now the difference in vector is this, from this to this point. It is very simple. Rotating is nothing but this is the origin, there was a particle here, the position of the particle may be considered as b vector. The particle has gone from here to here, so that the vector has changed from this vector to this vector, so it went through a small angle. Now the change is from here to here, from here to here, so the vector has changed. So what is the magnitude of the change? Let us call this as p, this as q, this as r. So this is our b vector and this is a new vector, because once it is rotated through an angle theta, the direction has changed. This is no longer the b vector. Let us call it b prime vector. But the only thing is, b prime vector is not equal to b vector because direction has changed. But because it is the same vector, it is just rotated, the magnitude hasn't changed. So b prime vector's magnitude is equal to b vector's magnitude, which is nothing but b prime is equal to b. So this is the change. pq plus qr becomes pr. pq vector plus qr vector is equal to pr vector. So qr is the change. So qr vector is nothing but pr vector minus pq vector. So qr vector is change in vector b. This is equal to pr vector is b prime vector minus b vector. So what is the difference in two vectors, which you already know this formula, that the difference in vector, the subtraction of one vector from the other. So r is equal to, if a is one vector, b is the other vector, a minus b vector's magnitude is a square plus b square minus 2ab cos theta. Otherwise you can also do this by doing a dot product. How is that done? So delta b whole square is equal to b vector, b prime vector minus b vector whole square. That means that b vector, b prime vector minus b vector dot b prime vector minus b vector. So when you do this, b prime into b prime is b prime vector dot b prime vector minus b prime vector into b vector, I mean these two multiplications and these two multiplications, minus b vector b prime vector minus b prime b vector into b vector, b prime vector into b prime vector. So you know the definition of dot product. A dot a is a square. So because a dot b is modulus a modulus b cos theta. So a dot a is modulus a cos theta. The angle between a and a is 0. Similarly, this is b prime square minus b dash b vector minus, these are all dot products, right? So b dash b vector and b dash vector both are same. So 2b vector b dash vector into b vector minus b into b, which is b square. The same is going to happen here. So it is b square plus b square minus 2b square cos theta. That's what is r, the magnitude. Here delta b square into delta b square is delta b square. The vector would be gone. So delta b will be equal to root over b dash square and b square both are same, because we already know that the magnitudes are equal. So it is 2b square minus 2b dash, which is again b square into cos theta. The same you would be arriving at. R is equal to root over 2b square minus 2b square cos theta, which is, you can take 2b square out, 1 minus cos theta, and root 2 times b into 1 minus cos theta. Here there is a trigonometrical identity I would like you to remember, or there is a video I've just posted, some useful trigonometrical identities for you. So in that, it is 1 minus cos theta is actually 1 minus cos theta is actually equal to 2 sine square theta by 2. So this could be written as, this is still within the root, so only this term we have taken out, this is still within the root. So root 2b into root over 1 minus cos theta can be written as 2 sine square theta by 2. So you can be taking that out, so it is root 2b into root 2 sine square theta. When you take root out, sine theta, sine square theta by 2 becomes sine theta by 2. Root 2 into root 2 is 2, which becomes 2b into sine theta by 2. When a theta is rotated through a small angle, then when a vector is rotated through a small angle, the change in magnitude of that vector is 2b sine theta by